In this video, we're going to talk about how to determine the distance between 2 points and also the midpoint between 2 points. And they, in fact, have formulas to help you do this. But before we get there, let's begin by talking about the Cartesian coordinate system. So this was formalized by René Descartes in 17th century. Now, you might not recognize this name, but all this is the XY plane. Okay, so something that you should be familiar with. So you have a y-axis that's vertical, okay, and an x-axis that's horizontal. Okay, so we have our x and our y, and they're perpendicular to each other. And then if we have a point on here, so let's say here's my point. Okay, it's going to have coordinates, let's say A, B. So what that means, it's always the x coordinate and then the y coordinate. Okay, so that means on the x-axis, we're at A, and on the y-axis, we would be at B. Okay, so this distance here is A, and this distance here is B. The middle of this plane, this spot here, is what we call the origin. Okay, so that's the center of the plane. So that's the origin, and its coordinates are 0, 0. So the coordinates for the other points are telling you how far away you are from this center point. Okay, so when you're at the center, you're 0 in the x distance and 0 in the y distance. Okay, so i.e. x equals 0 and y equals 0. So each point is described as an ordered pair, so that's what I mentioned above. The first value represents the horizontal position, so the x coordinate, while the second represents the point's vertical position. Okay, so when you're talking about the horizontal, so if A is positive, then you go to the right from the origin. And if A is negative, then you're going left from the origin. And if B is positive, then you're moving up. If B is negative, then you're moving down, right? So A is the horizontal position, whereas B is the vertical position. So when you're talking about distance between 2 points, if you're on a number line, okay, so let's say I have a number line and I have x1 and x2 on here. If I want the distance between them, this distance, it's just going to be, so we don't know which one is bigger. I've labeled it so that x2 is the bigger one on the number line, but we don't know. So if x2 is bigger, it's going to be x2 minus x1. So imagine, just for ease, okay, that 0 is over here. Okay, so then this distance would be x1, whereas this distance would be x2. So we want the difference between the two. Now, because we don't know which one is actually bigger, we can just insert some absolute values because our distance is always positive. So you just take the difference between the two, okay, and the positive distance, the positive difference. Okay, so if you get a negative number, you just make it positive. Now, if you have points that are two-dimensional, so have x and y coordinates, so x1, y1, and x2, y2, then the formula for the distance is a bit more complicated. So our distance, d, would be the square root of the difference in the x values, squared, plus the difference in the y values squared. Okay, so that's our formula, and I'm going to give you a brief justification for it. Okay, so they called this a proof. I'm going to say it's a proof idea. Okay, so not a full proof. Okay, but the idea is, and so I'm not doing it as general as I could. So I'm going to take points that are both positive. Okay, so let's say that x1, y1 is here. So this is x1 and this is y1. And maybe x2, y2 is over here. So there's x2 and there's y2. So the distance is going to be the straight line, the length of this straight line between them. So the length of that line is the distance. Okay, so what we're going to do is we're going to make a little triangle. Okay, so notice this is a right triangle. Okay, and then the length of this side is going to be x2 minus x1. And the length of this side is y2 minus y1. Okay, then all we need to know is the Pythagoras theorem. Okay, so remember that says that if you have a right triangle, where, that doesn't look like a right triangle, but where the legs, so the sides that are next to the 90-degree angle are A and B, and the hypotenuse is C, then you should have A squared plus B squared is equal to C squared. Okay, so given that, so using that idea, we know that D squared is equal to the sum of the squares of the legs. So that's going to be x2. That's going to be x2 minus x1 all squared plus y2 minus y1 all squared. So then when you square root both sides, you come up with the formula. Okay, so that's where it comes from. We also have this idea of the midpoint between 2 points. Okay, so if you have these 2 points, x1, y1, and x2, y2, halfway between them, we're going to have the midpoint. And it's going to have coordinates x1 plus x2 over 2, and y1 plus y2 over, over 2. Okay, now this one we maybe don't need to explain as much. Okay, these are just the averages between the x values and the y values. Okay, so that's where that comes from. So there is our formula for the midpoint. So let's just use these to find the distance between 2 points and the midpoint. Okay, so first we find the distance. So I'm going to call this x1, y1 and x2, y2. So then the distance is going to be the square root of 5 minus negative 3 all squared plus negative 1 minus 4 all squared. So that's going to be the square root of 8 squared plus negative 5 squared, which is the square root of 89, which is approximately 9.434. Okay, so you probably want to keep it as exact, okay, but that's the decimal for it. And then the midpoint is going to have coordinates, so it's the average of the x values. So minus 3 plus 5 over 2, that's the x coordinate. And the y coordinate is the average of the y coordinates. So 4 plus negative 1 over 2. So that's going to be 2 over 2 and then 3 over 2. So the midpoint has coordinates 1 and 1.5, or 3 over 2. So that would be our midpoint. Okay, so let's just do one more example here. Okay, so it says a baseball diamond. So we have a baseball diamond. The distance between 2 adjacent bases is 90 feet. Okay, and the shortstop plays halfway between the second and third bases. how far is the shortstop's distance from home plate. So I'm going to start by drawing a picture. Okay, now it's I'm going to draw it on its side here. Okay, so this is home plate. Okay, so here is first base. Okay, and this distance is 90 feet. Okay, and then we go up to second base, and then over to third base, and then down to home plate. Okay, so these are all 90 feet. So the shortstop is right in the middle here. Okay, so if we let home plate, if we think about this on the axis, and we let home plate be the point 0, 0, okay, then first base is going to be 90, 0, because I only moved horizontally. Oops. Okay, second base, now I've moved up 90, so it's going to have coordinates 90, 90. Okay, now for third base, I move all the way back to 0 for x, so it's 0, 90. So those are the coordinates for that. And then the shortstop, I've moved back half of 90, so here it's going to be 45, 90. And what we're looking for is the distance from home plate to shortstop. Okay, so that's what we're doing. Now these are all right edges here. So we can use, to find D, we can use this triangle here. Okay, it's a right triangle, and this side has length 45, and this side has length 90. Okay, or you could do just this position to this position. Okay, either one. So you can use Pythagoras' theorem, or you can use the formula for the distance, which is probably what I should do. So D is going to be the square root, the difference in the x values, so that's 45 minus 0 squared, plus the difference in the y values, which is 90 minus 0 all squared. So we get, if you expand those out, it's the square root of 10,125, which is approximately 100.62 feet. Okay, so that's approximately how far away the shortstop is if they play on the line. Okay, sometimes they play behind the line or in front of the line, but if they play on the baseline, then they're approximately 100.62 feet away from the home plate. Okay, there's two more examples on here. I'm going to leave them for you to try, and I will do them for you in a subsequent video.